Hey guys, I want to welcome everybody to the Big Bear Math channel. And we've got a really fun topic today. We're going to talk about the average rate of change of a function. And this is a really fun, popular topic that seems to show up anywhere from, seventh and eighth grade all the way through AP calculus. And so the quicker we gain some confidence in this topic, the better, because I think we're going to see it over and over and over again. So let's see what we got cooking here. Basically, in a nutshell, here's how we're going to define this, Bear. See if I can get. How fast is the function changing vertically? Okay, how fast is it changing vertically compared to how fast the function's changing horizontally? And I hope that sounds like something you've already learned earlier in your math career, and that's slope. We're basically trying to measure how much has the function changed vertically. That would be what we'll call our delta y, compared to how much it's changed horizontally, and that'll be our delta x. In other words, at the end of the day, we're measuring rise over run. It's really nothing new compared to that. So let's take a look at this first graph. And let's say, let's just make up our own interval here. Let's say we want to find the average rate of change over the interval from x equals 1 until x equals 3. So basically, and notice how I said that, it was from x equals 1 until x equals 3. So these are both x coordinates. So we're looking at this point right here up until we hit this point right here. So here's x equals 1, here's x equals 3 on that graph. And between those 2 points, I guess theoretically, there's an infinite number of points that lie on this graph. There's an infinite amount, and each one of them has their own unique slope. At the end of the day, we want to average every one of those together. And let's see. And if I can draw this line right here, this is what we call a secant line because it intersects and passes through the original function twice. And the slope of that secant line is equivalent to our average rate of change for this particular interval. So again, what we're trying to do is we're trying to measure how much has the function changed vertically, okay? So we're thinking, let's see, I went from a height of 4 to a height of 0 compared to how much it's changed horizontally. We went from a 3 to a 1, or from a 1 to a, however you want to word that. So we're thinking, if you think 4 minus 0 all over 3 minus 1, 4 divided by 2 makes 2. So 2 is the slope of this line right here, and that is your average rate of change. So I think if you kind of have this visual appreciation for it, it becomes less about memorizing a formula and more about understanding what it is we're trying to quantify or measure. But at the end of the day, this is all we're doing is, again, change in y divided by change in x. You've probably used this formula before, okay? And this formula is exactly the same as this kind of newer version, okay? This is probably the version you'll see going forward. And just think of it, when we say f of b, think of y sub 2. Let's see, this is your y sub 1, here's your x sub 2, and here's your x sub 1. So don't let this new notation scare you. All right. So again, our goal today is to find the average rate of change of a function over a closed interval. And basically that means like from x equals 1 to x equals 3 or something like that. And we're going to see functions presented in 3 different forms today. We're going to see function as an equation, as a graph, and as a table. And that's pretty much, we're throwing everything we can at you. And if you feel confident in those 3, there's nothing you can't tackle. All right. So here's my first form of a function in the form of an equation. And we want to find the average rate of change from x equals 1 until x equals 4. All right. So it's like, in other words, a equals 1 and b equals 4. So just maybe a little scrap work. We want to calculate what is f of 1. So I'm going to replace this x with a 1 to get 16 minus 1 squared, which makes 15. And we're going to calculate f of 4. This time I'm going to replace that x with a 4. So we get 16 minus 4 squared, which makes 0. So when we think of our formula, we're thinking f of 4 minus f of 1 over 4 minus 1, which is going to be 0 minus 15 over 4 minus 1, which makes negative 15 over 3, which makes negative 5. So there's your average rate of change, or your average slope over that interval. Now you may be wondering, is that a reasonable answer? Is it okay for my answer to be negative? Well, let's see if we can convince you from a graphical perspective. I'm going to graph this function right here, and I'm going to show you what that graph would look like. It is a parabola. It opens downward, and it's going to have a y-intercept of 16, and it's going to have x-intercepts of -4 and +4 here. And we did the average rate of change from 1 to 4. So we were going, let's say this is 1, here's 4, and we were trying to find the slope. I don't know if I can draw this. And so the slope of that pink line is going to be -5. So it's very reasonable that I got a negative answer because the line is sloped downward. For our next example, we're going to see this graph. Same graph we saw earlier. We're just going to see it from a slightly different perspective, or look at a different interval here. So this time we want to go from the interval x equals -1 to x equals 2. And you can think of this as your a and your b value. So if you think of f of b minus f of a, what we're really saying in this case is, what's f of 2 minus f of -1? So there's your change in vertical position. And then we want to do 2 minus -1, and that's how much the function's changed horizontally. So let's see. According to my graph, f of 2 is going to be this value right here. And so at x equals 2, the corresponding y value is a 1. Whoa. How do we get rid of this guy here? So f of 2 is a 1 minus, let's see. Now at x equals -1, I'm going up, 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 bang, right there. Okay, so now my y coordinate's a 4, so I'm going to go 4 all over, and we could say 2 minus -1 makes a 3. So we're getting, let's see here. If I clean that up just a little bit, we're getting -3 divided by 3, which makes -1. That's what we think our average rate of change or our average slope is. Now the question is, does that seem reasonable? Well, let's see if we can find the slope from this point to this point. Does it seem reasonable that the slope is -1? Well, check this out. Whoopsie daisy. All right. So what if I said, okay, starting here, I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. Boom, we landed right where we wanted to land. So slope of -1 makes perfect sense for that interval. All right, we've got one last approach we want to look at, and that's if the function is presented in the form of a table. All right, so here's my interval. Here's my a and my b. So now I'm thinking, what's f of 5 minus f of 0 over 5 minus 0? So in this case, how you read the table is you're saying, okay, when x equals 5, the corresponding y value is 1. And when x equals 0, the corresponding y value is a 26. So there's your change in y. And then 5 minus 0 is your change in x. So I think we're going to get -25 over 5, which makes -5. How about that? Another negative slope. And again, I think if we wanted to, we could always graph these points right along here, kind of construct our own little graph, and just draw a secant line to see if -5 seem reasonable or not. But I'm really confident in our answers. You can see these values are decreasing. And anytime the values are decreasing, we do expect a negative answer. So ladies and gentlemen, I hope that helped. Hope it helped a lot. And please, if you found that helpful, please hit subscribe below, share it with your friends. And again, we're always trying to improve with a growth mindset. So if you want to leave some comments down below how we can make this even better and more helpful, please do so. Other than that, have a great night.